Well, I'm back just to go over this year's exams, M23, and I heard that they've changed the time zones. It's like ABC, and so this is time zone A. As you can see, I'm just taking pictures of the exam itself because I have a copy, and we're just gonna go through it. Okay, so what do we got? We got a point P, we got a point Q, and we just need to find the midpoint, right? So this is just straight out of your formula booklet. You can just add the X and Y coordinates, or well, values together, and then divide them by 2. And then you should get your answer. So here's your midpoint. And then we need to find the gradient of L. L is perpendicular to PQ, and it goes through M. So this should be straightforward. First we need to find the slope or gradient of PQ. So 2 plus 8, and then -3 minus 15. At this point you should be finding gradients pretty easily, but if you don't, it's just in your formula booklet. -10/18. And then I don't bother reducing, which means that the gradient of L is the negative reciprocal of this, so 18/10. Then we need to write down the equation of L. They don't specify which equation, so I'm going to use the point gradient equation. So this is just y minus the y value of a point on the line, so I'm using m. And then it goes gradient bracket x minus the x value of m. Yeah, pretty easy. I think that's a very good first question to make people feel better about themselves. And then here's the next one, number 2. This looks pretty straightforward too. We have a rational equation. We need to find the 0. So in other words, we want to find out when the function is going to be 0. And whenever you do have a rational function, essentially for it to be equal to 0, the numerator needs to be equal to 0. And as long as your value for x that you get is not the non-permissible value, so in this case 2, then you're fine. So from here you can solve for x, and then you'll see it'll be -1. Okay, and then part B, write down the equation of the vertical asymptote. The vertical asymptote has an equation of x equals 2. That's the non-permissible value. The horizontal asymptote is the ratio of the leading coefficients. So in this case, that would be 7/2. So y equals 7/2. And then we're going to find the inverse. So I'm going to switch to using y instead of f of x. And this is a pretty standard find the inverse question. We can switch x and y at any time, so I'll just do it at the end. And I'm going to multiply get 2x minus 4 over to the left side of the equation, and then multiply the y in. And then the whole point is that I'm trying to isolate x. So I'm going to move this one over here. And then subtract this one over here. So that my x values can be together. Oh, it's kind of messy, whatever. And then from here we can factor out the x. And then we have isolated x. But again, this is a pretty standard question that you probably have seen in some, I don't know, homework or whatever. And then we can switch the x and the y. You can do it at the beginning too, not that it matters when you do it. So there you go, there's the inverse. Wow, not bad. And then obviously I've taken a look through the exam in general because I had to take a photo of everything. And I guess you can consider it like my 10 minutes of reading, but this exam seems not that bad, to be honest. But here's number 3. This one was kind of weird if you just don't know your statistics. So you have 40 visitors, and then this is how often they ride the dragon or something. And then you can assume that this sample is representative of everyone on the park. And then let's see, for the following day, estimate the probability that the randomly selected visitor will ride the dragon. So as you can see here, the only people that don't ride it are these 6 people out of the 40. So the probability that you will ride the dragon is the other part of this 40 people. So 34 people out of 40. Okay, and then we want to find the expected times a visitor will ride the dragon, expected number of times. So what we do is, to find expected value, right, we take the number of times and then we would multiply by the probability. And this isn't the probability, this is the frequency, but to change it to probability, we would put this out of 40. So what I'm going to do is I'll just multiply these all together and then divide them all by 40. So 0 times 6 plus 1 times 16. So again, this is x. So expected value of x. 2 times 13 plus 3 times 2 plus 4 times 3. And then I'm gonna just divide everything by 40 here. You don't have to do that. You can work with fractions instead and, you know, write each one of these frequencies as out of 40, and then that turns that into the probability. And then you multiply these together like a standard expected value thing. But it's the same thing. Oh my god, basic math. 0, 16 plus 26 plus 6 plus 12? What is this? 42 plus 6 is 48 plus 12 is 60. So 60 out of 40 for expected value. Okay. 1,000 visitors will attend the amusement park on Tuesday. The dragon can carry a maximum 10 people. Estimate the minimum number of times you gotta run the dragon. Okay. So we know that your expected value means that out of 40 people, Okay, this doesn't really make sense because it's an improper fraction. But the expected value is 60 out of 40. So if we multiply this by 1,000, this is how many people you can expect to be there or to ride the dragon in 1,000 people. Oh god, okay. Maybe I will reduce this. What is this? 3 over 2? 3 over 2 times 1,000. Okay. Oh yeah. Okay, so out of 1,000 people, we should expect this many rides. So if 10 people per ride, then this means you need what? At least 150 rides? Okay. It's a nice number, but this is paper 1. Okay. And then here's solving a trig equation. Pretty standard too as well. And then you're lucky for SLs in part A. You had a part A. Part B was just the question for HLs, so they didn't have that like helpful first step. But anyways, show that this equation can turn into this one. So the way we do that, use identities. So cosine double angle, and this is in your form booklet, is 1 minus 2 sine squared x. So we can just use the identity here. And then, you know, if you rearrange this, this becomes whatever they want. Yeah. So basically we just move these over here and then write the right side of the equation on the left side, and then this is how is what you get. Okay, and then part B. So as an HL, you're supposed to realize this on your own first, and then once you're here, you just need to solve this equation that you get. So we're trying to solve, I don't know why I'm writing it again, but we're trying to solve this. So this is a quadratic equation, so we can factor it. So we have 2 sine x over here, we have sine x over here. Both of these need to be 1, and this one needs to be +1, and this one needs to be -1. And then from here, we have 2 separate solutions for sine. So sine can be -1. Oh, and then one thing to note is this one is kind of particular with its domain. It wants from -pi to pi, so it's not your traditional 0 to 2 pi. So -1, sine is -1 at this angle here. So we can say -pi over 2. And then from this one right here, if we solve for sine x, this is positive 1 over 2. So that is here and here. We have sine being positive 1 over 2 on the unit circle. Okay. So we have this angle, and then from your memory, this is pi over 6. And then we also have to this angle right here, and then that's 5 pi over 6. then you're done. Here are your 2 angles, or 3 angles. Yeah, okay, not bad so far. Aha. So next up is probably the one that I think is, from a student perspective, the hardest one. Because you're finding the possible values of k such that this has at least one real solution. So we don't know what the solutions are, you just know how many there are. So this is a discriminant question. It says at least one, so that means that you could have one, which means that your discriminant could be equal to 0, but it could have more, it could have 2. So we're essentially going to solve this equation, the discriminant being equal to or greater than 0. But now the problem is that this is for quadratics, and it's a little hard to see where the quadratic is in this. But first we're going to move the left side over, because again the discriminant is for ax squared plus bx plus c equals 0. And yeah, this is a quadratic. Hopefully you guys can see that, because e to the x, e to the 2x is the same as e to the x squared. So you can consider e to the x as like these x's here. So you can identify what your a, b, and c are. So here's your a, here's your b, and then ln k, natural log k, is your c. And then, so our discriminant, which is a triangle symbol, what is it, b squared minus 4ac. So negative 3 squared minus 4 times 1 times natural log k. So this is 9 minus 4k. So we're trying to solve this inequality. It needs to be greater than or equal to 0, and that's not bad. We just solve for k. Oh, whoops, sorry, natural log k. And then we need to solve for k. So first off, we will isolate natural log k. So natural log k is going to be, oh, let's do this in 2 steps just to show you guys. First we subtract the 9, and then we divide the negative 4. So this is going to be 9 over 4. And then the inequality switches because you divide by negative 4. And then from here, that says flip. And then from here, we want to get what k is. So if natural log k is less than 9 over 4, then we change this into exponential form. And then this is essentially saying that e to the power of 9 over 4 needs to be less than k. And then just be careful with the way that this inequality works. So hold on, I think it goes this way. let me just think of how to explain this. So we want an exponent k so that e to the power of 9 over 4 here. Why don't I just explain it this way? If you don't understand, we can raise both sides to the power of e, and then these are inverses. So then you have k is less than e to the 9 over 4. But what I was trying to say is k is an exponent of e, and we want it so that we have it less than this exponent, which is 9 over 4, which means that, or k is not an exponent, it's the result of e to the power of something. So k, which is e to the power of something, needs to be less than this 9 over 4, which is an exponent. So the result is this, whatever. Anyways, just raise both sides to the power of e if you don't understand how that this represents an exponent. So this has to be an exponent of e. I spent too long trying to explain this. And then copy. And then now's a good time to say this because everyone always skips the beginning. But as I said, I literally am doing this on the day of the exam. I'm giving it 24 hours, of course, so that then I can upload it. But there's no mark scheme. And you're not going to get a mark scheme until IB officially releases it in like November or something. So I don't even know if I'm right. But SL stuff is usually not so bad. And I can generally get more or less all of the questions correct. And then HL gets a little bit messier. But anyways, here's the next one. So here we have a sine wave, and then it has a horizontal compression by Q. And then here's a diagram. Okay, find an expression for M in terms of Q. Well, whatever. Okay, so Q is a horizontal expression, or Q is a horizontal compression or expansion, and then that basically means that your period for sine, which is by default 2 pi, is going to be divided by Q. And then you can just look on your graph itself and see that the period is 4m. So that means that Q is going to be 2 pi over 4m. And then I'll reduce this one. So this is pi over 2m. And then from there, function g is defined as this. So you're going to need to sketch the graph of g. So there's a couple of function transformations that have happened. First off, we have a vertical expansion by 3. So your amplitude is larger. Now your amplitude of your wave is 3. And then what happens here as well is this. We have further multiplied the x variable by more things. So we have a horizontal expansion by 3 over 2. So you multiply by 2 over 3, which means that it's a reciprocal. You're going to expand by 3 over 2. Just like how if we multiply by q, you're dividing by q. You're basically dividing by 2 over 3, which is the same as multiplying by 3 over 2. But anyways, okay. So what does that mean? That means that your 4 pi period, right, is going to be expanded by 3 over 2. So it becomes 6 pi. And then we can sketch the graph because nothing else changes. So 0 will stay at 0. And then now our period is 6 pi, and that means that the middle of my wave is 3 pi, and then that means that 1.5 is the maximum, and 4.5 is the minimum. And then those are at 3 and -3. And then you can just sketch your graph. Ah, easy peasy. Okay, copy, next one. And then I think this might be the last short answer one. Is that an X? Okay, here's your function. It looks weird. And then we need to find the value of the y-intercept. So we're just gonna substitute in x equals 0. So if we do that, you get y equals 0 plus 3. So this is 3. Then you need to find the derivative. So I'll write that one over here. Okay, if you want to take the derivative, there is a product rule, because you have this x is being multiplied by e to the power of x. So we're going to use product rule. So derivative of 2x times ex plus 2x times the derivative of ex. And then we'll also need to take the derivative of 3, which is 0. So here is your derivative. And then in part C, hence find the coordinates of A. So you can tell visually that A is a minimum. So minimums happen when your derivative is 0. Local minimums happen where your derivative is 0. So we're just going to solve the derivative being 0. So you have 2e to the x plus 2x e to the x equals 0. And then from here, you can try to solve this by factoring, most likely. We can factor out 2e to the x, and then you'll have 1 plus x equals 0. Okay, so from here, there's only one solution for this being 0, and that is from this factor right here. So x needs to be equal to -1. Because as you hopefully know, an exponential cannot be equal to 0 on its own, because it's like e to the power of something. It's always going to be something. It's not going to be 0. Okay, so we found out the x value of A, and then we're going to, this is a little messy, we're going to find the y value, so we're going to plug it back into the original h. So 2 times 1 times e to the power of 1 plus 3, so this is 2e plus 3. So there's your coordinates for A. Hence, or whatever. Next up, show the second derivative is going to be that. Okay, well, I'm going to take my first derivative, and I'm going to take the derivative again. So this is pretty straightforward. It's the same thing. And then this is the same product rule as before. So 2ex plus 2x e to the x. But we want to make it look like this. And that's straightforward. These are like terms. So I can add these two. Oops. I can add these two e to the x's together right here. So these two can add to that. And then they kind of just tell you as a hint, because you know what it's supposed to look like, that you're going to factor out an e to the x. And then I'll get a 4 plus a 2x, and then this is more or less the same thing here. Okay, and then lastly, find the values that is concave up. So concave up means your second derivative needs to be positive. So we are solving this equation. And I'll write it the way that they wrote it. because this is a pretty typical, strategy for IB is generally in a multi-part question, even if you can't get the first one, that doesn't mean that you're not allowed to use it if you know it. So I'm just gonna use what they gave. It doesn't really matter instead of what I wrote. Okay, so when is this positive? So again, you're gonna need to note certain things about an exponential. This is always positive. So in other words, for the entire thing to be positive, we just need to find out when the 2x plus 4 is positive. And this is pretty straightforward. We're just solving for x. So x needs to be greater than -2. So as long as you're greater than -2, which is somewhere here, probably, you can see your function's concave up. Okay, that one's a little tough. And then we move on to the long stuff. Ooh, arithmetic sequences. Okay, let's see. The sum of the first n terms is given by the sequence. Find the sum of the first 5 terms. So because they just give you the formula, then why not just use it? S5. It's gonna be 5 squared plus 4 times 5. So 25 plus 20, 45. Okay, and then given that S6 equals 60, find U6. So S6 is basically just S5 plus the next term, S6 or U6. So we're just gonna subtract the 2. So I'm gonna take 60 and then subtract 45, and that should be U6. And what is that, 15? Okay, and then we need to find U1. So this one's also silly because I'll just write it right here. S1 is the sum of the first term. So S1 is the same as U1. So this is 1 squared plus 4 times 1. So S1 is 5, which is the same as U1. Hence or otherwise, write an expression for UN in terms of n. Okay, so wait, hold on. I know U1 is 5, and I know that U6 is 15. So we can find the common difference because this is an arithmetic. So we've added 5 differences, and you can see that basically what we've done is we've added 10. So that means that a single difference needs to be 2. And then that means that from there, UN is U1, 5, plus n minus 1 times d, which is 2. So there you go, there's UN over there. And then let's see, we have geometric sequence, U2 is U1, V4 is U6. Okay, and then find the possible values of R. So we have V1, we have V2, which is the same as U1, which is 5. We have V3, and then we have V4, which is the same as U6, which is 15, right? Okay, and then because this is geometric, then to get to V4, we multiply by R twice, so this is R squared. And then, actually, let me just write it this way, because you guys probably know this already. So v4 over v2 should be equal to r squared. So in other words, 15 over 5 needs to be equal to r squared. So r is plus or minus the square root of 3. And then given that v99 is less given that v99 is less than 0, find v5? Why do you need to know? Okay. Oh, of course. Okay, and then because you have two possible options, for the next question, for v5, there's two different options, so you need to know which one it is. So it says here that the 99th term is negative. So the only way that you can get a negative term is if your ratio was the negative one, because if it's positive root 3, then all of your numbers would be positive. So this just tells you that r is negative root 3. So then that means that v5 is going to be v4, which is 15 times r, which now we know is the negative root 3. So this is just negative 15 root 3. Okay, wow, not so bad, not too bad, this question. And then there's probably, what, 2 more long questions? And I'm doing pretty good for time right now, I think. Oh, what? I thought there was one more question. Whatever. Okay, this is question 9. So we have a kinematics question. Oh wait, oh, this one was a long one too. Huh. So this is the last question. Damn. Here's your equation for velocity. Blah, 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 blah. Okay. We want to find the displacement of the object from the origin at t1. So we want to find s1. Now, if you forget, right, a displacement function, the derivative is the velocity function. So we need to take the integral. Okay, so here's my function. I'll just rewrite it over here. Negative t cubed plus 7 over 2 t squared minus 2t plus 6. So this is v. So this means that s is going to be negative 1 over 4 t to the power 4. We're just using integral exponent rules here. It's pretty straightforward. I think it's in your booklet too. This is going to be 7 over 6 t to the power 3 minus t to the power 2 plus 6t, and then there's a constant, and then we should find out what the constant is, and then how we do that is we need to use this piece of information, right? Wait. Oh, I don't. Oh, wait, no, here. At t equals 0, the object is at the origin. Because this one's about velocity. I needed something about the displacement. Okay, so let me just move this out of the way. So this means that at s0, all of these terms with t would go away. I get c. And I know that the object's at the origin, so the displacement should be 0, which means that when you plug in 0 for t, all you get is c, which also means that c is 0. Okay, nice. Then we can find the displacement at 1. So if I plug in 1, then all I have are the coefficients of t. So I'm adding all of these together. Why would they do this to you? Ugh, fractions without a calculator? Well, they can both be 12, right? Okay, so this is going to be 3 over 12. And this is going to be 14 over 12. Can't change my colors right now, so whatever. Okay, so if I add those two together, I'll get negative 11 over 12. I need to subtract a 1, which is 12 out of 12. And then I need to add 6, which is, what, 72 over 12? No, sorry. Okay, fraction math. Great. Okay, so that's negative 33 over 12 plus 72 over 12. 39 over 12 meters. There you go. I don't know, whatever. I don't want to think about fractions right now, but that's how you do it. Okay, next up, find an expression for the acceleration of the object. So acceleration is the derivative of velocity, so we're just going to derive. So here's my velocity right here. So negative 3t squared plus 7t minus 2. Easy peasy. Okay, next. Hence, find the greatest speed at which the object comes to rest. So okay, greatest speed. Basically, we want to maximize v, right? So using calculus, we can optimize, and then that means that we need to find when the derivative is going to be 0. Find the critical points. So in other words, we're finding out when acceleration is 0. And also we will be checking boundary points as well. But we'll do this part first. So here's my acceleration. I need to solve when it's 0. I'm gonna divide by negative 1 because who likes having negative leading coefficients? And then this is probably factorable. 3t, t, and then one of these needs to be 2, and one of them needs to be 1. This one needs to be 2, and this one needs to be 1. Okay, so then I have t equals 1/3 and 2, right? Oh wait, I do not need it. Okay, so before it comes to rest, so I need to find out the maximum from here to when it stops, which means the velocity is 0 here. So as you can see, there's 2 places where your derivative is 0, and then obviously the fastest one is the larger value of t, which is in this case 2. So t is 2. Okay. However, we want to find the greatest speed reached by the object from 0 to 4. Okay. So speed doesn't have to be... Why are they doing this to you? Oh, because it says speed and not velocity. So velocity and speed are slightly different things, right? Like greatest usually means like the most positive, but speed doesn't have a sign. It's just a number. It's a scalar. So as you can see here, this value for your velocity is much larger than this value here. So technically you're going faster here. You're just going towards like the left, for example, faster than you've ever gone here, which is just going to the right instead. Okay, a little bit of physics knowledge for you. So what was this, E? No, D. Okay, so I'm just gonna plug in 4 into my velocity and then see what it is. And then again, here's my velocity function. This is disgusting. Fraction math? 64, 16, 8 times 7 is 56, minus 8 plus 6. Oh my god. Oh wait, I'm not done the first question. I'll go back and do it. Okay. What in the world? What is negative 64 plus 56? 8? Negative 8? Okay, I did not find the greatest speed. I just found out when the greatest speed was, so my bad. I also need to figure out what v of 2 is. Oh shoot. Okay. So I plug in 2 into my velocity function again, and then I do some math, some calculations. So what's 16 minus 8? 16 minus 8 is 8, right? Okay, so there you go. The fastest that it goes before it comes to rest here is this number. So that should be when the time is 2 seconds in, and then you plug in 2 and then you get 8 meters per second. So it's going 8 meters per second to the right or up or whatever. And then you want to find the fastest it moves, and the fastest it moves is going to be at 4 seconds because it actually goes 10 meters per second just in the opposite direction. And then lastly, write down an expression that represents the distance traveled by the object while its speed is increasing, but you don't need to evaluate it. Why did they bother asking this question? Distance traveled by the object while its speed is increasing. Okay, this one's kind of tricky because you need to understand what it's saying. So let me just redraw the graph here. Okay, quick question. This is velocity, right? So when is your speed getting faster? Not your velocity, your speed. So your velocity is getting faster from here to some inflection point right here. Right? Oh wait, no, hold on. Oops, not quite. I'm confusing myself. You can see it yourself. It goes faster from here to here. Actually, wait, no, but then it's still going fast. Oh my god. Am I getting my late night debuff? It's not even that late right now. Okay, speed increasing. So that is from here to here. You're obviously getting faster, velocity-wise. But also, you have to consider from here to here. You are also getting faster. So in this way, you're moving to the right faster, and then you're still moving to the right because your velocity is positive, but you're slowing down. And then once your velocity is negative, you're moving to the right, and you're continuing. Your graph is continuing to go down. So it means that you're going to the left faster. So these are the two places where you are going to have speed be increasing. Okay, so we know that this is at the minimum, which is 1/3. We know that this is at the maximum, which is 2. So we can find the total distance that it travels by integrating 1/3 to 2 of your velocity function. So that's going to be this distance right here, right? But we also need to find this distance right here. And that is going to be the integral from, I don't think they ever told you what k was, because they just said that it stops here at k, to 4 of your velocity function. And you'll probably need to actually write the expression, like this thing. And then keep in mind that this is a negative distance because you're moving to the left at this point. So if you want total distance, which is I think what they asked for, yeah, distance traveled by the object, we are going to subtract the negative part, which means that we're actually technically adding this to get total distance traveled. And then there you go. You are done the paper. So there's some tricky things, I think, but not too many. Overall, this paper is pretty straightforward. This one has some very interesting wording that you need to know your physics quite well to do it. Like speed versus velocity, whatever. But aside from that, it's pretty straightforward. I think that this is easier than last year's, to be honest. But there you go. And then I guess I'll do the HL stuff later. Okay, goodbye.